Have you ever looked up at the night sky and wondered, why is everything spinning? From the swirling arms of distant galaxies to the graceful rotation of planets and the dizzying spin of tiny asteroids, motion seems to be everywhere in space. Our Earth rotates once every 24 hours. The moon spins too, just slowly enough that we always see the same phase. Jupiter spins so fast that one day is less than 10 hours long. Even the sun, which looks still to our eyes, is actually spinning on its axis. And it doesn't stop there. Stars rotate, moons rotate, entire galaxies are hurling through the universe like giant cosmic hurricanes. It's like the entire universe is engaged in an endless, majestic dance, a cosmic ballet where nothing truly stands still. But why? Why does everything spin in space? Is this just a coincidence, or is there a deeper reason hidden in the fabric of physics itself? To answer that, we need to travel back in time, not just thousands or millions of years, but all the way back to the very beginning, because the secret to understanding this cosmic spin lies in the birth of the universe, the forces that shaped it, and the laws of nature that continues to govern every star, every planet and particle today. In this video, we will explore the mystery of rotation in space through 4 parts. First, we will go back to the very birth of motion, to the chaos after the Big Bang. Then we will break down the invisible forces and physics behind spinning objects. Next, we will discover how this spin shapes the universe and from stars to galaxies. And finally, we'll ask, will everything keep spinning forever? So get ready to zoom out, slow down time, and step into the silent yet powerful rotation that drives the cosmos. Because once you understand why everything in space spins, you will never look at the sky the same way again. To understand why everything spins in space, we have to go back, way back, all the way back to the beginning of time, to the moment of Big Bang. About 13.8 billion years ago, the universe was born in an instant, not with a sound or an explosion, but with a sudden expansion of space itself. In its earliest moments, the universe was extremely hot, dense and chaotic. Tiny particles were flying in every direction, randomly colliding, creating a swirling storm of energy and matter. There was no clear structure, no stars, no planets, not even atoms yet. But within that chaos, something critical was already happening. Motion. Some regions had more mass than others. Tiny imbalances led to the gravitational attraction, and as gravity pulled clumps of matter together, those clumps didn't just fall straight in. They began to spin. But here is the key. This spinning wasn't added from outside. It was already there, hidden in the random motion of particles. Even a slight, uneven push in one direction caused a cloud of matter to start rotating as it collapsed. And once that rotation started, physics locked it in. Why? Because of a law that governs nearly everything in the universe, the conservation of angular momentum. This law says that if something is spinning and nothing interferes, it will keep spinning. And if a spinning object shrinks, it spins even faster, just like a figure skater pulling in their arms during a spin. In space, when a huge cloud of gas collapses under gravity to form a star or planet, it spins faster and faster as it contracts. That's why stars rotate. That's why planets spin. That's why galaxies swirl. It all began with those tiny, imbalanced motions in the early universe, amplified by the gravity and preserved forever by the laws of physics. No giant hand reached into the sky and set the planet spinning. It was a natural result of the way our universe works. So, the reason why everything spins in space is because it had to. It's returned to the birth of the cosmos and is carried through the time by the unbreakable rules of motion. But this is only the beginning. The next part will explore what happens once these objects start spinning. How does their rotation affect their shape, their climate and their orbits, and even the possibility of life. Now that we understand why things start spinning and how that spin is preserved, Let us explore how this cosmic rotation shapes everything we see in the universe. Spin isn't just a leftover from the past, it's an active force that sculpts the present. Take planets, for example, the Earth's rotation gives us day and night. Without this spin, half of the world would stay in eternal darkness, while the other bakes under a relentless sun. That rotation, set in motion billions of years ago, defines the rhythm of life on our planet. And it's not just time that's shaped by spin. The very shape of spinning objects changes. Planets aren't perfect spheres because of their rotation. They bulge slightly at the equator. Earth, for instance, is a little wider around the middle than from the pole to pole. On fast spinning planets like Jupiter, that bulge becomes even more dramatic. But the influence of spin goes far beyond planets. Stars spin too, and in doing so, they churn and stir their fiery intentions. This affects their magnetic fields, solar flares, and even the way they live and die. When a massive star collapses in a supernova, its leftover core spins faster and faster, creating a neutron star or pulsar that can rotate dozens or even hundreds of times every second. Imagine an entire sun packed into a city-sized sphere, spinning like a cosmic top. It's mind-boggling. And one of the grandest scale of all, galaxies. Our own Milky Galaxy is spinning. Its arm winding gracefully through space, taking over 200 million years to make one full rotation. The rotation of galaxies affects how stars are distributed, how they interact, and how dark matter is mapped throughout the cosmos. Spin organizes the universe. It stabilizes the planetary system. It determines weather patterns. It drives magnetic fields. It even governs how matter collapses to form black holes, where spin becomes so intense that the laws of physics themselves begin to warp. In short, the spin that started as a tiny swirl of gas and dust billions of years ago now defines the architecture of everything, from the smallest moon to the largest galaxy. So now we come to the final, perhaps the most mysterious question. Will everything keep spinning forever? The short answer, probably not forever. But the long answer is far more interesting, and it takes us deep into the future of the universe. You see, in the vacuum of space, there is no friction to slow things down, the way it happens on Earth. That's why celestial bodies, once set in motion, keep spinning, sometimes for billions of years. But even in space, spin doesn't last forever. Over time, subtle forces begin to steal energy from rotating objects. One of them is tidal forces. For example, Earth's gravity pulls the moon and slows down the spin. That is why it's always show us the same phase. Likewise, the moon is very slowly making the Earth's day longer by transferring some of its angular momentum to our planet. And then there is magnetic braking, a process that slows down stars. As stars emit charged particles into space, their rotation gradually slows. The sun, for example, used to spin much faster than its youth. Over billions of years, it has been steadily winding down. In the distant future, many celestial bodies will become tidally locked, always facing the same side toward the object they orbit. The universe will grow quieter, more stable, and more still. And yet, even as the energy leaks away, the motion doesn't just vanish, it transforms. Spin becomes orbit, orbit becomes the heat becomes radiation, and on it goes. Because energy can't be destroyed, it simply changes form. So, while everything may not spin forever, the story of that spin, the force behind it, the effect it causes, will echo across time, shaping the stars, bending light, and carving the structure of the universe itself. In the end, spin is more than just a motion. It is memory, it is history, it is a fingerprint of creation, written in the dance of planets, the whirl of galaxies, and the silent, eternal tuning of the cosmos.